know electric field is denoted by E and the potential is denoted by V. We have also derived an expression for electrostatic potential, that is V is equal to 1 by 4 pi epsilon naught Q divided by R. So electric field is basically the force experienced by a unit positive charge. We know the expression E is equal to F divided by Q. Electric field inside a charged spherical conductor, the electric field is zero. Hello everyone, welcome to session 2 of chapter 2 Electrostatic Potential and Capacitance. This is Swati from Department of Physics, Vidyashram Pre-University College, the Temple of Excellence, Mysuru. In the last session, we have started studying about what is electrostatic potential, and we have also derived an expression for potential. So in today's session, let us discuss about some more interesting concepts. So let us begin with how the electric field and the electrostatic potential are different from each other. How do they vary with respect to a distance from a point charge? We all know the expression for electric field, that is E is equal to 1 by 4 pi epsilon naught Q divided by R square. So from this expression, we can say that electric field is inversely proportional to the square of the distance, and we have also derived an expression for electrostatic potential, that is V is equal to 1 by 4 pi epsilon naught Q divided by R. And from this expression, we'll come to know that potential is inversely proportional to the distance. So now from this and this expression, we can see that how the electric field and electrostatic potential vary with distance from a point charge, because these two are the expressions for the point charge. And graphically, they vary like this. So with respect to distance, the electrostatic field, that is E, graphically represented like this, and the potential is represented like this, which means electric field and electrostatic potential varies inversely with distance from a point charge. So let us now discuss about what are the other differences between electric field and electrostatic potential. We know electric field is denoted by E and the potential is denoted by V. So let us discuss about the differences one by one. So basic difference is, first we will define both of them. So that will be the first difference. So what is electric field defined as? So electric field is basically the force experienced by a unit positive charge. We know the expression E is equal to F divided by Q, the force experienced by a unit positive charge. Then what is electric potential? It is nothing but the work done in bringing a unit positive charge from infinity to a point against the electric field. So we all know that electric field has got magnitude as well as the direction, and hence it is a vector quantity, but the electric potential is scalar. So how this electric field and potential varies with difference for a point charge? It is E is inversely proportional to square of the distance, and V is inversely proportional to the distance. So this is the basic difference. The electric field and the potential vary with distance at the point charge. So it is measured, or the SI unit of electric field is Newton per Coulomb, because we know F divided by Q, N divided by C, which is equal to Newton per Coulomb, but the SI unit for the electrostatic potential is Joule per Coulomb, because we know V is equal to work done in bringing unit positive charge, so it is Joule per Coulomb. So here electric field inside a charged spherical conductor, the electric field is zero. We have derived this with the help of Gauss law, but the electric potential inside a spherical charged conductor is not zero. So these are the basic differences between electric field and electrostatic potential. So now let us derive an expression for electric potential at a point due to an electric dipole. This is very important, electric dipole. The word dipole means two charges separated by a distance of 2a. So for this, I have considered an electric dipole. You can see here we have plus q and minus q, and they are separated by a distance 2a. So it is an electric dipole. So let us take O as the center and center of the dipole, and P is a point at a distance of R from the center of dipole. Let O be the center of dipole, P is a point at a distance R from the center of dipole. Let the angle between this dipole moment and the line joining the point P and the center of the dipole be theta. So this is the angle, theta is the angle between the dipole axis and also the line joining the point PO. So this is theta. So now look at this figure. So in this we have angle POB. Here theta. Theta is an angle between the dipole axis and the line joining P and O, and also angle AOM are equal since they are vertically opposite angles. Now the potential due to plus Q at P is given by V1 is equal to 1 by 4 pi epsilon naught Q divided by BP. BP is nothing but the distance. Since we have no idea what is the distance between the charge and the point P where we have to find the potential, so it is BP. Similarly, let us write the expression for potential at P due to this charge minus Q. So that is given by V2 is equal to 1 divided by 4 pi epsilon naught minus Q divided by AP. Now, from these two expressions, we can get the resultant potential. The resultant potential at P due to 2 point charges can be calculated as V is equal to V1 plus V2, where V is the potential, V1 is the potential due to plus Q charge, V2 is the potential due to minus Q charge. Substitute the expressions in the place of V1 and V2. So that is V is equal to 1 divided by 4 pi epsilon naught into Q divided by BP minus 1 divided by 4 pi epsilon naught into Q divided by AP. Why minus sign here? Because we have due to minus Q charge, V2 is equal to minus Q divided by 4 pi epsilon naught into AP. So that is what we have substituted here, and we get minus 1 by 4 pi epsilon naught into Q divided by AP. So from these two expressions we know Q is common from these two, and we have taken Q common in the numerator. 4 pi epsilon naught is common from two expressions. So that is Q divided by 4 pi epsilon naught is the common term, and I can write the remaining terms inside the bracket, that is 1 divided by BP minus 1 divided by AP. So let us call this as equation 3. Now, we have no idea what is BP and AP. We must have some terms to substitute here to simplify and to get the expression to find the potential. So, let us now, with the help of this consideration or the configuration, let us now write the expressions for BP and AP. For that, we have to consider a point M here. So, the PO line is extended, or it is continued till M, and since the point M is closer to A, we have an idea of OP, but we do not have any idea what is PM. We do not have any idea what is AP, and we are considering now the point A is very close to M. We can say AP is almost closer to PM. Now, I'll consider this AP is equal to PM because of this condition, and we can write PM as PO plus OM. So, I get AP is equal to PO plus OM. But what is PO? According to the diagram, we know P is a point which is at a distance R from O. So, PO is R. So, I get AP is equal to R plus OM. That's my equation 4. But what is OM? So, for that, let us consider this triangle. This is a right angle triangle where this angle is 90 degree. So, from this right angle triangle, AMO, we can say cos theta is equal to OM. This is the adjacent side of the hypotenuse. So, cos theta is OM divided by AO. When minus Q and plus Q are separated by a distance of 2A and O is its midpoint, what is the difference from one point to O? That is A. From O to another point, that is A. So, from this, cos theta is equal to OM divided by OA, that is adjacent divided by hypotenuse, and from this we can write OM is equal to OA cos theta. That's my equation 5. But what is OA? We know OA is nothing but A. So, we will get AP is equal to R plus A cos theta, as I have shown in the figure. AO is equal to A, and I am substituting the same in the above expression. So, I get AP is equal to R plus A cos theta, that is my equation 6. Similarly, in this way, if we consider the other triangle which is vertically opposite, we will get BP is equal to R minus A cos theta, and after simplification you arrive at this equation that is BP is equal to R minus A cos theta. That's my equation 7. So, let us substitute now 6 and 7 in equation 3, because we had the equation 3 as Q by epsilon naught into 1 divided by BP minus AP. Now, we got BP and AP terms. And let us now substitute that. So substituting equation 6 and 7 in 3, we get V is equal to Q divided by 4 pi epsilon naught into 1 divided by Bp minus 1 divided by Ap is my equation 3. So in this I am substituting AP and BP terms. And I am replacing the AP and BP terms with the R plus A cos theta and R minus A cos theta. And I get V is equal to Q divided by 4 pi epsilon naught into 1 divided by, in the place of BP I am substituting R minus A cos theta. In the place of AP I am substituting R plus A cos theta. Now, let us simplify this. So, now from that we get V is equal to Q divided by epsilon naught. In the denominator, we have R minus A cos theta and R plus A cos theta. So, taking the LCM, we get R plus A cos theta minus, because we have minus sign here. So, minus R minus A cos theta. Now, let us see this thing. So, we have A plus B into A minus B. So, this is of the form A plus B into A minus B, which is nothing but A square minus B square. So, let us expand the denominator in the same format. So, we get R square minus A square cos square theta, because in the place of A, I have R. In the place of B, we have A cos theta. So, expanding that, we get R square minus A square cos square theta. See, come to the numerator now. So, it is R plus A cos theta minus R minus A cos theta we have. So, writing this, expanding, so we get R plus A cos theta minus R, minus into minus becomes plus A cos theta. Now, plus R and minus R will get cancelled. Now, A cos theta plus A cos theta give us 2A cos theta divided by R square minus A square cos theta. But look at this expression now. V is equal to, here in the numerator we have Q and 2A. So, what is Q into 2A? It is P, which is dipole moment we have studied in the previous chapter. So, I am replacing these terms with P and we get the equation V is equal to 1 by 4 pi epsilon naught P cos theta divided by R square minus A square cos theta. We know that the distance of A is very much smaller when compared to the R, because A is the distance from midpoint to one charge, but R is the distance of separation between the midpoint of dipole to a point P. So, R is very much greater than A, and hence the terms of A square can be neglected and we can write the expression as V is equal to 1 divided by 4 pi epsilon naught P cos theta divided by R square, which says that the potential due to a dipole depends on an angle between the position vector and the dipole moment and also the distance, that is R. So, this is the expression for the potential due to an electric dipole. So, in the next session, let us learn some more interesting concepts and few derivations. Until then, keep learning all of you. See you all in the next session. Thank you.